From the beautiful Way Happy Studios, it's Mr. Meyer.
Thank you, Sally. And it is Mr. Meyer coming at you with the unit circle. And the funny thing is, I'm probably not even going to mention the unit circle, but we're going to talk about radians and we are going to talk about how you can do things without a unit circle. And then maybe we'll introduce that unit circle tomorrow. So here we go. You need to know about radians. Radians are awesome. Just like we measure degrees, and we already messed around with it. We got 0 degrees, and we got 90 degrees, we got 180, and we got 270, and then all the way around is 360. Well, again, bothers the heck out of a lot of us because it's a made-up number. Why the heck 360? Why not 400? Why not 210? Why not 73 degrees is a circle? Some math geeks love to say, we like radian or degrees are cool, but we wish they were a little more functional, that they actually had a value. And remember from your good, amazing geometry teacher that circumference of a circle, all the way around, was the same thing as 2 pi times the radius, 2 pi r. So what if I decide to make the radius of my circle 1? And that's really why it's called the unit circle, because it's 1 unit radius. Well, that means the circumference all the way around the circle would just be 2 pi. So that's actually kind of helpful, because all the way around the circle would be 2 pi, which means if we break this into little chunks, we would have chunks of that 2 pi. And that's really what a radian is. A radian is the angle that we measure, but instead of degrees, which really don't mean anything, we have chunks of a circle or circumference, which is 2 pi. So all the way around the circle, instead of saying 360, math geeks say 2 pi. So next time you're snowboarding with your friends and you bust a 360, go, just dropped a 2 pi on ya. And they would be like, whoa, that guy knows radians, right? So, hey, try it out. Now, here's the hard part. You got to get used to it because you've never done it, and it's kind of fancy. But a whole revolution is 2 pi, which means if we decide to only go halfway around, well, then that's not 180 anymore. That's just pi. And now you got to be a little good with your fractions. Like, look, if that half a rotation is pi, then if I only went straight up to 90 degrees, what the heck would that be? Well, it's a whole pi is to the left. So that means that this is only going to be a half a pi, or what most people will call pi over 2, but I'll call it a half a pi for now. So 90 degrees is half a pi. And then cut that in half. Well, heck, that's pi over 4. Right? Because it's a fourth of a pi. And over here, say I'm over here and say I'm exactly 45 degrees in this way, I have 3/4 of a pi, or what we call 3 pi over 4. Crazy, right? And then when you finally get past pi, that's when you start going over 1 pi, but you're still shy of 2 pi. Like straight down, this right here is 1.5 pi's, or what we like to call 3 pi over 2. And so that is radians, plain and simple, right? Instead of saying 45 degrees, I say pi over 4. Instead of saying 30 degrees, I say pi over 6, because it's 1/6 of a pi, right? 30 degrees. Now you're saying, wait a minute, you're throwing too much at me. It is. It's going to be nice to memorize. However, there's always a conversion, and that's what the box is over here next to me, right? This is the conversion that you need to know if you want to do this. It's pretty simple. It's based on the idea that you know something. You know pi is the same thing as 180 degrees. And if you know that, you can convert anything from degrees to radians or radians to degrees. Notice here, if I want to go degrees to radians, I just multiply the degrees by pi radians over 180. If I want to go radians to degrees, I multiply by 180 over pi. And that is if you've done any chemistry and you've done your dimensional analysis. That's what they're talking about there. They're converting things to different units. That's all you're doing. So here we go. I got negative 60 degrees, and somebody wants me to convert that to radians. Not a big deal. I take negative 60 degrees, and I multiply it by something. But this unit, right, has to be a 1. You can't just multiply it by a number and expect it to be okay. Well, I want the degrees to cancel, so I'm going to need degrees in the numerator. And I need a conversion like, I don't know, 180 degrees is pi radians. And because that's a true statement, pi radians and 180 degrees are exactly the same, that's like a fraction just being a 1 right here. And so I'm multiplying 60 degrees by 1, which isn't going to change it any. And all I can tell you, though, is that, look, boom, degrees will cancel, and we will have negative 60 pi radians over 180. And I bet I could simplify that down a little bit, like the zeros could cancel. So that's 6 pi over 18. Hey, wait, that reduces a little more to pi over 3 radians, and that's what you get. 60 degrees is just pi over 3 radians. Nice, right? What about 2 pi radians? What if you had to go the other way? You're like, maybe I ask you, hey, graph me 2 pi over 3 radians, or 2/3 of a pi. Well, it wouldn't be too bad, because I know that this is pi, and I know 2/3 is like right here somewhere, right? So maybe that's a little more like 3/4, but we'll pretend it's not quite all the way to 1 pi. It's a little shy, right? This is 2 pi over 3, or 2/3 of a pi, almost all the way to 1 pi, which would be 3/3. What if you want to know it in degrees, though? You're like, I don't know where that is. Fractions scare me. So what do? You take your 2 pi over 3 radians. I guess I should put the word radians in here. And you multiply it by 1. And so I need radians this time on the bottom. And I need a conversion that's legit. Can only multiply by a 1. Can't change the value any. And I happen to know that 180 degrees is pi radians. By the way, you could use 360 and 2 pi if you wanted. It wouldn't matter. And you'll notice that pi radians cancels pi radians. And the next thing you know, I got 2 times 180 degrees all over 3. Now, at this point, if you want, multiply the 2 and the 180 together. If you don't want to, you want to reduce, that's fine too. 2 times 60 degrees, and you have 120 degrees, and you know exactly where it is now. You could graph it. And that's the joy. So what do we have to know? Remember our 2 special triangles, right? We got the 45-degree angle, we got the 30-degree angle, we got the 60-degree angle. Well, we know this is 0. We know this is now a half a pi, or what we're going to call pi over 2. Well, we just converted 60 degrees, happened to be pi over 3. I think earlier I showed you pi over 4 and pi over 6. So there's some stuff if you want to memorize it. Otherwise, you could always convert it. But it is pi over 2, pi over 3, pi over 4, pi over 6, right? And then 0. Now, it's weird. You want it to be pi over 5, but it just doesn't go in nicely. So there you have it. You have your radian measures in quadrant 1, which will also represent your fingers, right? There's your thumb. There's your first finger, your middle finger, your next finger, your little pinky finger. You're like, yay! So now if you can start to get used to that, we can actually have some super fun with it. And we'll be able to calculate everything in degrees and in radians. And radians have some cool properties for arc length and stuff like that, which we'll do in class. But let me see if you can convert a radian or 2, and then we'll come back and we'll use it with reference angles. And that's really fun. Excellent work. Now let's look at this. All students take calculus. That's right. All of them take calculus. You have to. It's the way it is, right? Why do we know that? It's a little thing to help you with the signs. And I'm talking about these signs, not S-I-N-E-S. Humor makes me laugh. All right. So all students take calculus. Look at the quadrants, and you know this is quadrant 1, and this is quadrant 2, and this is quadrant 3, and this is quadrant 4. So that's the order that all students take calculus goes in, so you can remember it. And what does it actually do? Well, it helps us remember who is positive in which quadrants. So if you have an angle, so you're doing some angle that's in over here in quadrant 1, the A stands for all. All your trigs, well, let's talk about the 3 basic ones, sine, tangent, and cosine. All 3 will be positive in quadrant 1, right? Say, no, take it back. You have an angle in quadrant 2. You have an angle in quadrant 2, then that's the sine tangent, or the S quadrant. That means sine's positive, and cosine and tangent are negative. Say you got an angle sitting here in quadrant 3. So you draw your angle, you're like, oh, quadrant 3, well, tangent's going to be your positive one. Everyone else is going to be negative. Sine and cosine will be negative. And I guess you're getting the hang of it. If you draw an angle that happens to be in quadrant 4, then your cosine is your positive value, and sine and tangent are your negative. So that's your little mnemonic for all students take calculus. That will tell you who's positive and who's negative right away. So it's kind of cool. I see a sine of 30 degrees, say, and it's on a test. And answer A, right, is negative root 3 over 2. And answer B is root 3 over 2. And C is 1/2. And D is negative 1/2. Right? Well, if I know where 30 degrees is, that's right here in quadrant 1. Whoops, that's a really bad initial side. In quadrant 1, that tells me I know right off the bat they're all positive, so sine's positive. I can already rule out these two answers and say that's bogus. Right? Now I just got to do the finger trick, fold down that 30-degree angle right here, and sine's right here. It's 1/2, and I'm like, sweetness. The answer's 1/2, and everybody's happy. So that's what we're going to do now, and we're going to do it with radians, and we're going to do it with degrees, and we're going to jump all over the place. So here's super crucial steps. Get that keyboard out of here. Super crucial steps. I'm going to throw something at you, and you will then have to decide what quadrant you're in so you can get the sine. Then you find the reference angle so that you can use your fingers. And then once you can use your fingers, you can answer the question. So that's our steps to success and our joy for trig. So are you ready? Let's try cosine of 225. Panic. So first thing my brain is thinking is, where the heck is 225? Well, I know here's 180. I know here's 275. So it's down here. That's 225. It's in all students take. It's in the quadrant where tangent is positive. So since they're asking me cosine, I know the answer is already negative something. So my answer is negative. Okay? So negative answer. Now we figure out the reference angle. So the reference angle is getting me back to the x-axis. So if this is 225, then what's the difference between 180 and 225? That's 45 degrees. And now the cool part. Now you look at your hand. So remember, this finger is 45 degrees. So you fold this guy down, and we're doing cosine, so that's the top fingers. We would have 2 fingers on this side. So the answer would be root 2 over 2. And that's how I go through this whole process of solving what it is. It would be, in fact, negative root 2 over 2. And there's my answer, and everybody's like, what? How did you do that? Now your goal is to get really good, to do it all in your head, right? That's your goal. But at first, draw it and be comfortable with it, right? Let's try a sine of 330 over here. I'll void the radian for a second before you freak out. Let's try the sine of 30. So again, 330. I got to figure out where the heck 330 is. So it's over here somewhere, right? There it is. All students take calculus. Cosine is the only positive one, so the answer is negative. I got to figure out now the reference angle, which happens to be 30 degrees. And now I take my hand and I fold down the 30 degrees. Cosine is the top fingers, so it's root 3 over 2 when I look at my hand, and I'm done. I just did it. Right? Boom. Finished. All right, let's do the last one. And that's it for the night, right? Let's try this, and then we'll get tons of practice in class. Where the heck is 5 pi over 6? So you're like, oh, switch my brain to radians, right? Well, this is a pi, and 5/6 of a pi is not quite 6/6 of a pi. So that's like right here, 5/6 of a pi. In fact, it is 1/6 of a pi short. How do I know? Because this is 6/6, right? This is 1/6 of a pi short. So the reference angle is 1/6. Oh, forgot. All students. S, sine's positive. This answer happens to be negative. Well, all 3 were negative. Now I find out the reference angle, which happens to be just pi over 6. So then I go to my hand, which, depends on... Wow, that's really nice. Remember, this is pi over 2, this is pi over 3, this is pi over 4, this is pi over 6, and this is 0. Now look, fold down that pi over 6 hand, And you want tangent, which is just the bottom fingers over the top fingers, the sine over the cosine. That's all it is. So what is that? The bottom fingers is the square root of 1, and the top fingers is the square root of 3. And we're supposed to remember it was negative, so what the heck is that? That's negative 1 over root 3. Or if you don't like it like that, then multiply top and bottom by root 3 so nobody yells at you. And you get negative root 3 over 3, and that's your tangent of 5 pi over 6. And you are now doing some crazy fun trig. Now the unit circle, if you're curious, is all these numbers thrown on a circle at once so you could look at it. But my goal now is to be like, hey, I don't even want you looking at the unit circle. I want you using your hand and your brain and doing it all. So we're going to practice this a ton. We did already in class. We're going to do more with radians now. So you got to start getting comfortable with radians. All right. Have a great day. Stay happy. And I'll see you tomorrow.